UTC Overseas is a global logistics specialist in heavy, oversized, and mission-critical power generation equipment. What you're about to see is a fundamentally different approach to industrial rail pre-clearance, and the foundation of their partnership with the New Orleans Public Belt Railroad and Port of New Orleans. UTC holds a U.S. patent on an AI system that predicts rail clearance constraints for oversized cargo. Powered by Palantir Foundry, it replaces static drawings and weeks of coordination with a predictive, data-driven workflow, evaluating load, railcar, route, and historical outcomes before anything is submitted. Why New Orleans? New Orleans is America's heavy lift gateway. The port offers over 13,500 feet of dedicated breakbulk berthing, 1.6 million square feet of transit sheds, and direct ship-to-barge capability, built for cargo others can't handle: power transformers, generators, reactor vessels, and energy infrastructure equipment. But the decisive advantage is on the rail side. Through the New Orleans Public Belt Railroad, cargo gains access to all 6 Class 1 railroads: BNSF, CSX, CPKC, Norfolk Southern, Union Pacific, and CN. NOPB is the only deep water port in North America with access to all 6 Class 1 railroads, reaching over 30 major inland hubs and virtually every industrial corridor in the US, Canada, and Mexico. By carload volume, NOPB is the nation's 4th largest rail gateway. That is why industrial rail pre-clearance belongs here. The connectivity is unmatched. What the UTC platform adds is the intelligence layer that makes that connectivity commercially visible before equipment is purchased, manufactured, or shipped. From the dashboard, we define the route, load, and railcar, and the patented workflow begins. The system extracts dimensional data, determines viable routes across the NOPB network, pulls historical outcomes, and generates a real-time clearance probability. What you're seeing is a digital twin of the railcar and load, not a static drawing, but a live model built from exact geometry, weight, and center of gravity. That twin moves through a digital rail corridor evaluating real conditions: bridge load ratings, clearance envelopes, track curvature, cant, lateral movement, and vertical dynamics. The clearance envelope updates dynamically, flagging tolerance risks in real time. Past approvals and denials feed the model continuously, turning individual experience into institutional knowledge. What used to take 6 to 12 weeks of manual engineering review now happens in seconds. When ready, submission is automated, generating railroad-specific packages in the correct formats, including NOPB interchange recommendations for the optimal Class 1 carrier. The project returns to the dashboard, closing the loop from prediction to decision to learning. That's UTC's patented industrial rail pre-clearance platform, built on the only U.S. gateway that connects to all 6 Class 1 railroads.